Hello friends, welcome to my channel. Today I am going to explore under computer architectures and operating system post-fit memory allocation techniques. Let's go. In dynamic memory allocation scheme, the operating system must keep a list of each memory location, noting which are free and which are busy. Then, as a new job come into the system, the free partition must be allocated. These partitions may be allocated in 4 ways. First one is first fit memory allocation, best fit memory allocation, third one is worst fit memory allocation, and next fit memory allocation. Today we explore the worst fit memory allocation. In this allocation technique, the process traverses the whole memory and always search for largest partition, and then the process is placed into the partition. It is a slow process because it has to traverse the entire memory to search the largest partition. Here is a flow diagram of this algorithm. I'll simply explain to get brief idea about this first fit algorithm, how it is work. I assume that the user should provide a list of memory block size and the list of process memory requirements and the system functionalities. The system should simulate the worst fit algorithm for memory allocation. It should display the allocation results including process ID, allocated memory blocks, remaining sizes of memory blocks after allocation, like that. First, in this simulation, first we input the free memory block or partition and processors. After that, the processor check the process queue. Is there any processor and how many processors are there? If there is a process, then traverse all the blocks of memories and get the largest memory block, and after the select the largest block, then check the block size with the process size. If it is sufficient for this process, then it allocate to the memory block and that memory block updated. It traverse until the all the input processors evaluated. If there is any insufficient or insufficient memory block, then it print the cannot allocate message after all the processors or none of one is input, then the simulation goes to the end. This is the simple flow diagram of worst fit algorithm that I explained to you. Let's go to the simulation part. It's very helpful for you to understand how the worst fit algorithm works. And okay, this is the simulation part, the worst fit algorithm simulator. I'll develop for you to understand how these memory blocks allocated to processors, how allocated to the memory blocks. We can enter the memory blocks in a real world scenario. This is not work like that. The main memory has memory blocks. It's initialize the memory blocks. We cannot define it, but in this simulator we assume that we can add the memory block sizes and how many memory blocks we can that we can explore with this simulator. First I'll add some random sizes for these memory blocks, 200, 300 or 500. This is input the memory blocks and the process memory requirements. For processors I'll add some 100 to 100 and 300, like that. After click this simulate allocation, it shows the allocation results in this table. You can explore and you can easily understand that these P1, P2, P3 and P4 is which are the input processors that we made in this area. First it get the first process 1, and this is the process size, and it allocated to the block 3. Now we can explore how this block 3 choose, because this block 3 size we can check. Block 3 is 1, 2, 3. This is block 3. This size is 500. This is the largest block available in this memory, all the memory blocks. That's why this first process is allocated to the block 3. This is the main idea of this worst fit algorithm, worst fit memory allocation. Then we go to the second process. Its process size is 200. This is also allocated to the block 3. If we remove the first part, the second is 200, the process size. Then we check the block 3. The available block 3 size is 200. Why it is like that? The first is 400. After the process 2 is allocated to the block 3, then it is goes to the 200. The remaining part is 200 in this block 3. Then we goes to the process 3. Process 3 processor size is 100. The 100 process size is allocated to the block 2. We check the block 2. Block 2 size is 300. This is the largest block in this free available allocated blocks. It allocated to the block 3, then it is goes to 200. Then we goes to the process 4. We add the process size as a 300, but in this scenario the 300 in this all the blocks there is no 300 size block, then it is goes to the not allocated, because these process sizes cannot sufficient for any 1 or 2 or 3 blocks. This is the simple simulation of the worst fit algorithm. Then I briefly explain for more information, more knowledge for you to how these tables and how these simulation developed with JavaScript. Now can see the JavaScript code that I developed for this was fit memory allocation. Okay. First I initialize the first memory allocation variables and the process variables, and it assigns as an array with the input areas. After that, first it check the memory blocks include any value. Memory blocks and processors our input has any values. If it is not, then handle the output message invalid input and please enter a number of separated by commas. It returns the program is goes to end. Previously I explained as in flow diagram. After, if there is a value, then it is separated with the commas and get the array, and I initialize another allocations and pre-blocks. The pre-blocks variable stays for check all the memory blocks that we input to the simulation and get only the free blocks. If there is any memory block full, then it is removed from this free block size, because we only the processors can allocate it for the free blocks, block or partitions. This is table, HTML table that I input show the thing in the table. In this part, all the input processors one by one get the index and process, check get the input processor one by one, and check the free block. Under free block, it check the block size larger than less than or equal to the process, and largest block size is larger than the largest block size. Current block size is larger than the block size. Then if there is any new current largest block size, it applied to the current largest block size memory block. Then if there is a largest memory block, if there is a null, we first assume that is null. If there is a null, then program is goes to end. If there is a value, then the allocation memory variable is updated with the process index and processor size and the largest block ID, and the largest block size is reduced with the newly allocated process size. The largest block size is equal to 0, then the free block site remove the largest block index from the array. Previously, like I previously said that. Then it is updated in as a row in the table with the process index, process size, and largest block ID, and the free blocks map. If the allocation is failed, then the allocation could not be allocated message to the table row. This is the simple code, JavaScript code that I developed to simulate this was fit memory allocation technique. It is more simple technique. It is not used in real world scenario because there is a lot of disadvantages, such as really slow, because every time all the memory blocks should be search for a largest block, and there is a lot of fragmentations. These are the disadvantages. Also some advantages with the memory allocation, because there can allocate the largest memory block for first time. It is very helpful for that. This is the coding part. Next time we meet with another memory allocation method. Until that, thank you all of you.